All right, so this presentation is about Seamless Immutable Cursor, which is a library I just wrote. I'm Martin Snyder, the CTO of Wingspan Technology. And what this whole talk is about is immutability in JavaScript. So for people that are fans of functional programming, immutability gives you a lot of benefits when you're dealing with data structures in general. And there's three commonly used alternatives for doing immutability in JavaScript. So the most popular is Immutable.js that came out of Facebook. The second most is a library called Seamless Immutable, and the third is Deep Freeze. And Deep Freeze and Seamless Immutable use a very similar technique, so we're just going to be talking about the first two. But ultimately, what I determined is even though Immutable.js is the most popular, Seamless Immutable is a much more effective library to use in many cases, especially when you're dealing with React. So Immutable.js, what they do is they implement persistent data structures, which is exactly how functional programming libraries work when they're doing their lists and vectors and maps and stuff. And persistent data structures in general have incredibly low cost write operations and low cost all operations. So they're very high performant. One of the issues with Immutable.js, though, is because they implemented their own data structures, is that when you want to use them with some other JavaScript library, you have to convert them to a compatible structure, usually a JavaScript array or an associative array or something like that. And that's a copy operation coming out of Immutable.js, and there's a cost associated with that. But there's another little nugget there, which is a problem, I think, which is that once you've copied it into that compatible structure, the copy itself is not immutable. So if you pass it to some library and the library is changing something, you won't know, and that change will be lost. And all of that is it's not going to cause a bug in your program, but it may hide behaviors which you would rather know about. So Seamless Immutable is exactly the opposite. It doesn't create any new data structures. It works exclusively with JavaScript's existing data structures, and it uses an ES5 mechanism to freeze the object. So when you freeze an object, it can no longer be modified. You can't add or remove attributes. You can't change the attribute values. But freeze is pretty naive. Like freeze will not, for instance, if you freeze an array, it will not freeze the elements of the array. Or if you freeze an object, it will not freeze the objects that it refers to. And that's where the name for deep freeze came from. Is that it will just, you freeze an object and it will then recursively freeze everything that can be touched. And that's exactly what Seamless Immutable does. And so when you write to an object that's been frozen, this is a very high cost operation because we have to create a copy of the JavaScript structure and then move a bunch of stuff over and then refreeze a bunch of things for that new structure. And so the cost of writing is significantly higher than using Immutable.js. The nice thing, though, is that there's no conversion cost at all to make a compatible structure. This is why Seamless Immutable is called Seamless, is that the immutable structures that it is managing can just work natively with all JavaScript objects, JavaScript libraries, because there's nothing exotic that it's doing. It's just using the existing structures. And then the other nice thing is because you're passing around compatible structures, which happen to be frozen and therefore immutable, if some library does accidentally try to touch something, that will throw an exception and fail, and that's the desired benefit. So, this is definitely more of a bare knuckle approach. It's not a pure, functional programming concept for Seamless Immutable, but it's very effective in achieving immutability in JavaScript. So the interop is the whole reason it exists. If we didn't care about interop with other JavaScript libraries, then Immutable.js would be the only thing that people used. One of the things it does, which is a little bit hidden, is if you're doing a common routine on an immutable structure like a concat or a map or something, Seamless Immutable replaces all of those routines in the libraries with things that will refreeze the result. So if I map over something that has been frozen with Seamless Immutable, then the resulting array that it spits out, that will also be completely frozen. So once you enter the immutable world, you don't leave it, which is, that would be a really common source of problems when you're dealing with the technique that is used here. So it rewrites pretty much everything so that you are, you kind of, like I said, once you enter the world, you don't leave. And you don't really have to do a lot of work with Seamless Immutable. You create these structures and then you start using them. You don't have to keep revisiting that over and over again. Seamless Immutable has a lot of conditional logic to handle edge cases. Like for instance, a JavaScript date, if you freeze it, just doesn't work correctly, breaks. a React control, a React class, if you freeze that, it won't work correctly. And that's like a really common use case when you're dealing with things in React. You have some data, like an array, passed in as a React property, and you're going to map over the array and convert it to some subordinate React control, and you want that to work. And so Seamless Immutable detects all this stuff and just doesn't freeze things that can't be frozen correctly. So it saves you as the user of the library from having to know what can and can't be frozen. There's been a lot of work done there. And then one of the things that's the obvious downside that I mentioned previously is that the write cost for Seamless Immutable is incredibly high. And if you're dealing with smaller data structures, it won't be high enough to notice. So that's you just kind of write that off. But if you're dealing with something that's really big, it can impair your application. So the nice thing is that there's a release build of Seamless Immutable that actually doesn't freeze anything at all. And so that makes the write cost the same as it would normally be for any JavaScript object. And you might ask, well, then how does it enforce immutability? The answer is it doesn't. So there's a release build that does not enforce immutability. But if you've been developing with immutable structures and you've been testing with immutable structures and the application fails if someone touches them by accident, then you can infer that, for the high likelihood, your application is actually treating them immutably and you get all the benefits without the cost. If you go to the website, he recommends not using that release build unless you have a performance problem. You want things to actually be immutable. But if that ends up being a problem, if you want all the other benefits and this is the only thing holding you back, then you can eliminate that. So now we get to cursors, which is the thing that I wrote to pair with Seamless Immutable. And so when you're dealing with immutable structures in any sort of realistic application, you very quickly realize that the structures themselves are immutable, but the application has this changing state. And cursors are one of many techniques to manage kind of generational iterations of a global immutable state. And so that we're going to have evolutions of this thing that happen over time. There's a second thing that cursors do, which is kind of nice, which is cursors can give you a window like down into some hierarchical structure. So rather than pass this one giant thing around, you can take some small nugget and you can pass just that small nugget around and people can operate on that. Now, when you're writing to an immutable structure, you have to have the whole structure available to you. It's the only way it can possibly work. If I was, because when you write to an immutable structure, you're going to create a new copy of the immutable structure, which has your change applied. And so if someone were to pass some little subordinate nugget around and you were to change that, like you have to change the big guy, right? You can't just change this little nugget. And so cursors have access to make the change up at the top, even though it looks like they're addressing some minor bit. And then you have all these changes happening. You have to have some way to detect them, right? Because you're not if you're passing a cursor around to some subordinate structure and somebody thinks they're changing some nested element and is actually going to loop back to the top and change the entire thing, someone has to be notified about that so you can go and do the right things. And then we talk about cursors with React because one of the best current use cases in JavaScript to use immutable structures is with React, because React is based significantly on functional programming concepts. React has a lot of things in it that it wants to be immutable, and by convention, you never change. This lets us have strict enforcement of that. So a lot of one programming technique with React is called Flux, and with Flux, you keep all of your application state in a single object actually above your React hierarchy, and you just pass the parts down as necessary. So this makes a trivial Flux implementation. When you're doing things that way, your application state only comes through React properties, and it will be forcibly immutable such that no one can ever touch it. So you get all the right properties in a React sense. And that leaves your UI state would only be exposed through what is called React state. Now, all these things are going to work the same way, but we have a clear division in our application between the application state and the UI state. So one example of UI state, because a lot of people, if you don't visualize it exactly, you might be confused as how you would know the difference. So one really easy example, if you imagine, I have a change password feature. I have like a user profile, which it's not going to list the passwords. I can change my name and submit without blanking out my password or something. That password control might have a little button to click to say, hey, I actually do want to change my password, and I click it, and it converts it to an edit field, and now that would prompt the user, and it would get sent up. Which state that thing is in, whether it's in that blank state waiting to be triggered, or whether it's been triggered and is now accepting input, that is exactly the kind of UI state that you would use a React state for instead of your application state. So we get that strict enforcement of the props, which is nice. And the other thing is that we don't actually pass the cursors into React. Like the cursors have a very tiny bit of overhead, and they have these capabilities. But the only reason to pass a cursor instead of the data the cursor refers to is if you want to change it. And your React world will never be changing it. So you just pass the data. You don't worry about the cursor at all. The cursor just goes to your controller, like some, a promise handler off an AJAX request or something like that, and it will be updating the cursor as you want. And this lets you have pure React components. And a pure React component is a component whose output depends only on its properties and state, and in our case, we'll generally not be using state at all. And so these pure components, they can do reference equality on their properties without doing a deep equals to see if their properties have changed. And if the properties haven't changed, not render. And so what this means in terms of Flux is you can take like your gigantic monolithic data and you can drop it into your React world. And with these optimizations turned on, React will only modify what actually changed, which gives you huge performance benefits. It turns out if you do it this way, you usually don't need those performance optimizations, but you get them for free, so you might as well take them. So let's take a look at what this looks like. So we have a little application here. We're going to restart the page. We're going to take a look at the code. So this is the import. This is the demo is part of the project. So we're not using a normal module reference. We're just including the source file directly in the demo. And so we can create a cursor with this cursor constructor, and we can pass any structured data to the cursor for the initial state. So that's my application state that I've created. When you talk about what sort of things you can put into a cursor, generally the rule of thumb is if it can be JSON serialized and deserialized, then it's safe to put in there. And if it can't, well, you might be able to get away with it. Like you can put like function references and stuff in here, and seamless immutable will probably do the right thing. But you really just want it to be data that is going into the cursor. And so now we have a root cursor for our application. And there's two things that we can do on a cursor. We can refine it. And when you refine a cursor, that's how you get a subordinate cursor. And you can get the data from it. And that gives you a read-only reference to the data. And then you can also assign a value to the data so that the data in the cursor is going to look, we're going to look at it in the debugger, it's going to look like a property. But when we assign a value, it's actually going to do that feedback loop where it's going to, given that cursor, go up to the top and then apply that change just to the right location, create a new generation, and it's going to fire this change event. So we have our initial state up here, and if I just move this a little bit, we can see that part of what we're rendering is that documents array. So we can see the two documents just as JSON right there. And then we get a change event here, and the change event includes the next data and the previous data, which is again a very common pattern when you're talking about immutable structures, so you can do edge detection and figure out. It also passes a reference to the path that actually changed, which you can use for various purposes. But in our case, for a React render, anytime anything changes, we just render our whole world. So if you've been doing this from inside React using like React State or something, it's the exact same technique that React is using. You're requesting a change, the change gets applied, and then the render cycle is executed. And we've just taken control of that at a higher level. And then I have a set interval function, which every second is just going to get this messages portion and is going to just put a new pulse onto the message. So we can see as it goes on, it keeps doing that. And that's the only interaction. So right here, we get this refined cursor, which is a window to just that messages array. Okay, and the current messages is the message cursor.data, so that would be an array that starts off with just that initial value. And then we call concat on that, and we have put a new string into the messages array. Okay, and then concat is returning a similarly immutable thing, which we assign back to the data. That fires an on-change event, and so we come here. And that's pretty much exactly how you build applications. Is you don't really need to invoke render ever. All you have to do is just do one thing, which starts the avalanche. Usually it's like an AJAX call to the root of a RESTful API or something like that. And then the user actions will trigger subsequent changes, and every time the app state is changing, cursor gets written to, and the system renders, and that's it. And then for convenience, I take that root cursor because we're buried inside a JavaScript module, which is great, except if we're trying to debug stuff, you have to set a breakpoint in the module to see what's going on. So we're just going to take that root cursor, we're going to put it right on the window. Okay, and that helps us from a debugging perspective. So this application's running. I don't have a breakpoint set at all, and I can just say window root cursor, and we'll look at its data. Okay, and so you can see there's 232 messages, and I can keep doing that and see how the application is changing. Okay, and then I can do a refine, and we already have it in there. We'll refine. We'll get the messages array, and from the debugger, I can change that application state, and you can see that this change fired an event just like my application would, and forced a render, and all the right things happen. Okay, so we can interact with the cursor from the debugger. We can see the entire application state. We can navigate through it, and then this doesn't change anything else we have or know about our JavaScript application. All the other techniques are on the table, but we get this little added bit. So let's just take a quick look here. We said before that Seamless Immutable is locking these things down. So we'll naively come into our message list here. So this is, if you haven't seen this before, this is a I don't know if it's ES6 only, but typically you see it only with ES6 React components, is if you have a pure component which only has a render method, then you can name the component as just a function that operates on named properties through this syntax. And so this defines a React class called message list, which has one property called messages. And this render method gets that and acts on it. And in this version of React, this is not technically pure. This does not optimize away the render calls that are unnecessary, but in a future version, they're saying that it will. So this is a highly compressed syntax. And then there's this awkwardness where if you want to do a little extra stuff like prop types or something, you have to write back to the function that you created. And the JSX compiler makes sense of all this for you. But let's just say I'm a poorly behaved developer, and I'm trying to hack around a bug to meet a deadline. And so I've determined that I just need to overwrite these messages if they're, whatever the condition is. So if I have any messages at all, then I'm just going to make the first message, equal the empty string. And I'm going to save that. I'm going to run this, and we'll see that, we get exactly the sort of error we would expect if someone's trying to write to something which is read-only. And that times a million through your entire application. You set it up this way, you are guaranteed that nobody is doing an unsafe write to a React property. So there's other benefits as well, but in the context of React, that's pretty much all that it is. So let's come back to our slides. There are a couple things that you can demonstrate with this technique. There's other presentations on it and stuff, but just kind of to get people's, if you're not aware of these techniques, two really common implementations that fall on top of this is we have all our application state up at the top, and you saw how we could interact with it in the debugger. It's very simple to implement, like for instance with Control-C, Control-V keystrokes, copying that state into JSON into the clipboard and then pasting it back in. Right, so you can imagine, some user. Let's pretend it's an internal user in your organization who you have a relationship with, or not some random person on the internet, but they're reporting some defect, and you're like, well, I can't imagine what you're describing. Why don't you Control-C the application and email me that buffer? And you get this email, and you copy it out of the email. You stand up that version of the application. You paste it right in. You should see comparable behavior. Their application state applied to your running system. There's a lot of very powerful things you can do armed with a technique like that, and it's trivial to implement from the point where we're sitting right here. And the second thing is that when you're dealing with immutable structures in general, this cursor is this nerve center which is controlling all the transition activity, and we get change handlers coming off it. I can trivially implement history features. Now you put a little more thought into that. Like for instance, we might not want those messages to be part of the application history, so we might break that off into another cursor, or who knows exactly how you would structure that. But you can store, a sequence of things, and you can implement then an undo feature. Or if this was, like a chess game or something, you can store all the moves and then replay the game from the start. All sorts of things, and you get a lot of those features for free. Basically, well, render this state, now render this state, now render that state, versus our change handler, which is always just rendering the current state. So there's a lot of different things that you can do. And there's more as well, but these are the two that are most common when you talk about immutable structures, when you talk about React, when you talk about user interfaces that are built on these techniques. So there's a few links here. The top one here is the link to the project in GitHub. It's open source, of course. It's published to NPM. Seamless Immutable is the library it's all based on. Interestingly enough, in my Cursor library, there's only 2 references to it. It's really, because Seamless Immutable, once you enter its world, everything stays that way. All that we have to do in the Cursor library is touch the initial values and make them immutable, and then the Cursor library will just keep regenerating things. And then my blog has links to all of my work and presentations. So thank you all for listening, and if there's any questions, I can take them now. We can also take a look at the Cursor source code, which is pretty short, if people are interested in seeing how that works.